we can see in the global coverage that we have a clear differentiation between regions. There is mostly widespread coverage in China as well as in the United States, and sort of mid-level in Europe and Australia, New Zealand region, with lower coverage in Africa, South America, and also the Middle East. In this sense, in this case, we are talking about the 5G basic. Let's say it doesn't cover also the mid-band, which would be beneficial also for some of the use cases that will be required for some of the use cases that we will talk through in this presentation. There is also some challenges. So in this graph, I've tried to show the benefits that 6G will bring over 5G and why we are already talking about 6G and how is it needed. So for example, in terms of capacity, there are already 1.6 billion contracts in 2024 for 5G telecommunications. And it is expected that the user experience data rate of these contracts will triple from the values from 2022 to 2030. Additionally, a benefit that 6G can provide is added accuracy. So up to 30 times more accurate in terms of location, and perhaps even more importantly, higher energy efficiency. So with improvements of over 300 times the efficiency of 5G. Then this leads us to the main 6G goal. So what is really the target for 6G over 5G? With connected intelligence, programmable, deterministic, integrated sensing, sustainable, as we mentioned about the energy efficiency improvement. It has to be trustworthy. Also on the privacy, we will see a few use cases and presentations from our colleagues on privacy, and also, of course, there's the solution to the affordability and scalability issues of 5G. So, which I will talk about here now. There's, of course, a downside of 5G. I believe I've had a quick look at the presentations that we will see today, and this is mentioned. The European Commission calculates the cost of the network expansion at 33.5 billion euros, of which 30.8 is expected to come from the industry, and only about 2.7 would come then from subsidies and government investment. So this is in an area where, in a moment where telcos are struggling to recoup the investment in infrastructure. There's been really big investments in up to 4G, 5G from telcos, and the return on investment for that infrastructure is not really seen by the telcos. So this means that complementary business models are required in order to ensure the correct coverage of 5G and also to ensure the viability of the networks in the future. So in this sense, looking for new use cases and new business models, I've here mapped some projects and use cases that are doing exactly this, and having focused in 4 key areas of improvement that 6G will bring. I've tried to map some of the projects that are related to enable 6G and also previously unlock. So, for example, in terms of the latency, we can see projects from Nebulous regarding the use case crisis management, and also the AROS project with the use case of Smart Edge for Continuum. Our colleagues from IMDEA will talk today also about some use cases, but we can see in terms of the energy demand, they worked on the system architecture for battery-free IoT networks. So regarding Li-Fi and other low energy applications. And then for capacity, we have the Fluidos and the NEMO project with the use cases robotic logistics and smart media city and XR. And then finally for the privacy use case, increased privacy use cases in the project NEC LAB, the remote healthcare applications and use cases, as we saw, healthcare is expected to take a big part of the have a big part of the impact, economic impact in 2030. So this is a very interesting use case in that sense. Then also our colleagues from Telefonica will be presenting the privacy preserving AI use cases, which for sure will have a very big impact in the future. And then in the ICOS project, there's also the use case of in-car advanced infotainment and multimedia management system. So with that, we have a whole presentation with many interesting projects. I hope I could contribute a little bit to paint the bigger picture of where 6G fits and where we will be in 2030. And yeah, thank you very much for listening. Back to you, Brendan.
Thank you very much, Jose Luis. And I think putting into context there that we need to start talking about 6G now because the applications that are going to require these networks are getting more and more complex. And I think that's one of the key interesting parts of what Enable 6G is doing and what we're trying to discuss here today is, how are we going to increase that capacity? How are we going to ensure that we have the infrastructure in place? And how are we going to make sure that it makes business sense for everyone involved? I think that's one of the key things that we'll be talking throughout the day, and also looking forward to how really the building the business case for the network also relies on the maturity of what's happening in terms of the edge continuum, but also all the different areas there, and really unlocking that value that we can achieve with all the technologies that are converging at the moment across this area as well.
6G networks, the aim is to go beyond the current use cases for 5G in terms of communication, for providing extremely high data rates and ultra-low latencies for communication. The other keyword that we have here is big data analytics. So with 6G, there is going to be an explosion of data. And it would be really interesting for us as researchers to leverage these huge amounts of data in form of machine learning or AI models. The other keyword in this overall objective is localization. When it comes to 6G, location data will play a very huge role like never before in providing complex services in 6G, and that is why we have it as a keyword here. And the other keyword is privacy-preserving solutions. So with 6G, there are going to be opportunities to provide more and complex services, and also there will be a likelihood of an increment or an increase in the privacy threats. So that is why it is important for us as researchers to build systems that are privacy preserving at the same time.
The privacy and security implications that we've heard about also before, right? Sort of you want to run machine learning on this. Now, the first question is, how do you extract that data in the first place? Where to run the machine learning? And how to do this in a way that's privacy preserving for the user. Those are very interesting, important questions that we address. And with this, let me conclude here.
Thanks, Joerg. And what looks almost like sci-fi is actually a reality. And as you say, the main thing is that we need to start also making sure that it goes in tandem with the work that we're talking about in MAP-6G of that privacy and trust element, especially as we get more and more interesting in how we're using our networks. And I think the applications are going to be enormous in this area as well, long term.
Starting from nowadays, basically, we are in the rollout phase of we are starting the rollout phase of the new 5G technology, and we can already see the unprecedented experience in communication and localization performance that is conveyed to the end users. However, we have to balance these technological benefits to costs and drawbacks that this technology is providing. In particular, 5G and beyond 5G, 6G indeed. Base stations will exhibit unsustainable hardware costs, and newly introduced transmission solutions will be highly complex and in turn power hungry. Moreover, as anticipated before, we will rely on higher frequency bands that will directly influence on the propagation property of the communication themselves, and they are impaired by the huge material penetration that will require in order to have service coverage to base station densification process. So in turn, it will again increase costs of deployment.